Yesterday, we looked at the concept of portfolio theory and how the risk of investment and the risk of a portfolio is measured. I explained that for an investor to diversify, for we to say that, what do you say? Away risk that investor must have invested on 2 or more investments that are either negatively correlated or have a correlation of 0. And I explain what we mean by correlation. And covariance. And we went ahead to look at how to compute return on a portfolio. So we now started to look at the risk of portfolio. I haven't looked at the risk of individual investment, where I said that the risk of an investment is measured by standard deviation. Okay, standard deviation. And the standard deviation measures the degree of deviation of our required return from expected return. The difference between what you are expecting and the actual result is what we call deviation. It's what we call deviation. And that is what our standard deviation measures. Okay. So
Sorry, I have
we'll continue from. You said?
I have a question. This covariance AB, in the solution that you did, the second one, covariance is you said deviation A multiplied by deviation B times probability. But now this formula here, I'm saying standard deviation A times standard deviation B times this correlation A.
I think it's a question.
My question is, the formula you use for covariance, to solve covariance, if you scroll down, the formula is deviation A times deviation B times probability. This one, yes. This covariance AB, you use deviation A times deviation B times probability to get covariance. Or the new formula you just gave.
Which one is new formula? Which one?
This one.
Which one is new formula?
This one is standard deviation A times standard deviation B times correlation of A and B. This covariance formula.
Yesterday now.
What?
You had once delayed the class around 10 o'clock yesterday, and eventually you did not join.
So you did not even call me. I slept off. I was expecting that I will receive a call.
When we have agreed that we start by 10.
Yes, I was.
And it's difficult because you said you do something until 10.
Yes,
and we delayed the class at 10. You did not join. Now, I said we have 2 formulas for computing covariance yesterday. And one of the formula is this. And if this formula was gotten from here. Okay, I think I've, okay, yeah. That formula was gotten from here. This is the formula for correlation coefficient. Okay, that's the formula for correlation coefficient. From this formula, we just simply make covariance the subject of the formula. Now, I'm not saying that in a situation where you are having two investments, like we have here, let me go to the question so that you understand what I'm talking about. Portfolio theory. Okay. Let's go to the question. Now, if you look at this question here, investment A and investment B, both of them have the same probability. What's that? This 27% return from A and 35% return from B have the same probability, 30%. The same thing with 18 and 15. The same thing with 5 and 20. So in this situation, if I want to compute my covariance is simply deviation A times deviation B times probability. Do you understand?
Yes, sir.
But in a situation where I already have my, look at it, I already have my standard deviation of A, and I have my standard deviation of B. Let me go to that formula. Where is it? Where I already have my standard deviation of A, I already have my standard deviation of B, and I already have my correlation coefficient. Then I don't need to go to that route that I went to up there. I just say that my covariance of AB is equal to standard deviation of A times standard deviation of B times covariance, times correlation of A and B. If you look at this question now, we have what's our standard deviation?
A.
Of A. Answer that?
Yes.
Good. What about standard deviation of B? This one, have you?
6.4.
Where is it? 8.5, have you? This one.
8.5, okay.
So standard deviation of A, the standard deviation of B already have. Now, what about correlation? Do I have correlation before?
No.
No. I mean, the answer is what? The answer is no, isn't it?
Yes, sir.
So because I don't have correlation before, I will have to go and calculate for me to get my correlation, I need to compute covariance first in this question. And that's why I have standard deviation of A times, deviation of A, no standard deviation, deviation of A times deviation of B times B, so that my covariance. I will now go and use that formula now to get my correlation. I did because correlation, and I have computed my standard deviation of A, standard deviation of B. I will simply say covariance AB is equal to correlation times standard deviation of A and standard deviation of B. So it depends, the formula you are using depends on the information you have available. Do you understand?
Yes, sir.
That are correct. There's no issue. But it depends on the information you have. Did you understand that?
Yes, I get, sir. It depends on the information given. Now determine the information to use.
So the second one that we started dealing with is risk of the portfolio. And yesterday we said portfolio is a collection of two or more investments. When you have two or more investments, we say that you have a portfolio of investment. You have a portfolio of investment. So I can assess the risk of my portfolio, meaning that I want to measure the total risk of all my investments. One risk for all my investments. That's the risk of the portfolio. And the risk of the portfolio, we said, is given by what? It's given by this. Okay? Standard deviation of, variance of A, this variance of A times weight of A. And what did I say weight of A is? I said weight of A is the proportion of your investment that you have invested in investment A. Okay? The total sum of your money that is invested in A. Maybe you have two investments, for instance, investment A and investment B. And you have invested, let me say you have 1,000, like I used yesterday, and you have invested 400 on investment A. So it meant on investment A. That is what we call weight of investment A. Proportion on investment A is the weight of A in the portfolio. Okay? So that's what this WA represents, plus variance of B times 1 minus weight of A squared. Okay? 1 minus weight of A squared. Now, when we say weight of 1 minus weight of A, it simply represents weight of B. Why? Like the example I gave there, if I have put 40% on investment A, it means the balance I'm putting on investment B is simply what? Is simply, what do you call it? Is simply 1 minus 40%. Okay? It's simply, please, this one should have square weight of A square. Sorry. Okay, let me see. Let me see how I can manage you. This one should have square. Okay, yeah, square. Yeah. So weight of A superscript A, yeah. So weight of A square. So if this is weight of A, let me say 40%, it means weight of B is 1 minus 40%. You understand? This formula, I don't think this is part of a formula sheet. So just I think it's important that you know this formula. So when we are done, the next one is plus 2 times standard deviation of A times standard deviation of B times weight of A into bracket 1 minus weight of A square times covariance AB times covariance AB. Are we there? Hello? Are we there?
Yes, sir.
So that's what we started looking at. And square is not there. So we started keying in our information yesterday. This is the variance of A. The square of standard deviation is variance. So you simply pick the standard deviation of A and square it. And the weight of A, we calculated yesterday under requirement A, we have 0.4. And the variance of B is the square of the standard deviation of B, which is 8.44 square, times weight of B is 1 minus 0.4. That is 1 minus weight of A. Weight of A is 0.4. Therefore, weight of B is 1 minus 0.4 plus 2 times standard deviation of A. Standard deviation of A is 8.57 times standard deviation of B. Standard deviation of B is 8.4 times weight of A. Weight of A is 0.4, then times 1 minus 0.4 times covariance AB. What's the covariance we calculated yesterday? Our covariance is 43.5. 43.5 is the covariance. So that's how you are going to input all those variables in your formula. So let us evaluate what we have in this formula now and see what we are going to have. Where's my calculator? 1 minute. Let me bring out my calculator. I want to do this. Oh. I'm not sure I brought my calculator from the office. Okay. Not sure. But my calculator in the office. Okay, can you use your calculator to get that? I don't think it's like I left my calculator in the office. What is 8.57 square? Hello? Give me a figure now. Well, 8.57 times 8.57.
73.44.
Times root of A square times weight of root square. So this one should have a square, weight of a square. So weight of a square, I will have 0.4 times 0.4. I have 0.16, then 8.44 square, 8.4 times 8.4. I have 70.56, 70.56. Then this one now is going to be 0.6 square. Yes, 0.6 times 0.6. 0.6 times 0.6. That's giving me 0.36. 0.36 times 2 times this times this times this, okay? I go to the next line. I will evaluate this further. 73.44 times 0.16. So 0.16 times 73.44 will give me 11.75. 11.75. 11.75. 9.75 plus 70.56 times 0.36. That's 25.40. 25.40. 25.40. Then I now have 2 times 8.57 times 8.44 times 0.4 times 0.6. It's giving me 34. So the whole of this place now, the whole of this place, okay, let me even complete it, times 43.5. So I have everything here is giving me 1.028. 510.27. That's what that one will give me. Then I will evaluate further again. When I evaluate this one further, I will add everything together. Add everything together. I have 11.75 plus 4 plus 1510.27. I have 147.42. I will take the square root of this. Square root of this, give me what? Okay, come in. Square root of square root of 0 point, sorry, say 0 point. Square root of 1547, 1547.42. give me what? Will give me 89.33, 39.33. That is the risk of the portfolio. That is the risk of the portfolio. So that is how to measure or calculate the risk of a portfolio. That's how to calculate the risk of a portfolio. Are we there?
Yes, sir.
So let me check. I'll show this. I'm sure there is some mistake in our multiplication here. Okay, let me go through the formula again. I think this thing seems to be too high for me. Let me confirm this. This 0.4. This is not 0.4, 0.44. Let me check. Where's our weight? Oh, okay. This one is 0.44. Not 40%, this is 44%. This is 44%, not 40%. And this one is this one should be 0.56. 56%. I think that's a little this here. Yeah. So plus 2 times 8.57, 8.44 times 0.44, 1 minus 0.44. There's a little mistake there. Then times 43.5. Covariance AB. Yeah. Okay. I think we should be fine now. But I don't think there's going to be much impact on that final solution. That 0.04 is not significant. It's not that significant. Two times standard deviation of A, standard deviation of B, I want to ensure this formula is fine. I see where the issue is. Good. Now look at it. You know, I said yesterday that your covariance can be calculated as what? Standard deviation of A times standard deviation of B times what? Correlation of A and B. So I'm not supposed to use, if you look at this place now, 2 times, this is standard deviation of A, this is standard deviation of B, Abi? So because I've already used standard deviation of A and standard deviation of B, I'm not supposed to use covariance again. What am I supposed to use? I'm supposed to use correlation. So this is what I'm using. I know that figure is so high. I'm supposed to use correlation because I already have standard deviation of A here I have standard deviation of B here. And that's what I have in this formula. So the moment I introduce correlation here, it means I already have covariance. Is standard deviation of A, standard deviation of B, and correlation. And that's what I already have is from standard deviation here, then correlation. But if this one is not there, these two here, then I'll just have 2 times weight of A, weight of B, times covariance. Do you understand what I'm saying? If these two here is not there, if I didn't use standard deviation, then I will just put, it will have been, this is what I'm saying. I will put it back. Let me remove this. I did not put this one initially. If this is what I have, 2 times weight of A, weight of B. So A, it could have been covariance. Here, I will have just put covariance AB. Because there is no standard deviation here. But the moment I have my standard deviation there, standard deviation of A, standard deviation of B, then I'm not supposed to use covariance again. I'm supposed to use correlation. So this should be what? 0.6.
I mean, there are 2 different formulas.
It's not different. It's still the same formula. Okay, let me state it this way. Let me repeat this formula. That's what I'm saying now.
Okay.
Let me remove this one here. 2 times weight of A times weight of B. Then I'll copy this one here. I want to show you what I mean here. Now, this formula here, okay, and this one, sorry, and this one here, they are the same. Because this one, the one I highlighted there means what? Covariance. So I can just remove it and put what? Covariance. Sorry. I can just remove this one and just put covariance AB. Because I know that covariance AB is setting as what? Is setting as this. So this is just a kind of shortening the formula. But if I don't want to shorten the formula, I put it this way. Standard deviation of A times standard deviation of B times correlation of A and B is the same thing as covariance A. So instead of me using standard deviation A times standard deviation B times correlation, I can simply put covariance AB. So it's not 2 different formulas. It's just that you are short, one is longer than the other. Basically, they are the same thing. So this is what will guide you. Since you know that covariance AB is standard deviation of A, standard deviation of B times correlation, then you are fine. So it's not 2 different formulas. They are the same formula. It depends on how you want to put your figure. So A, I will remove, if I want to use covariance A, I will not put standard deviation here. But since I put standard deviation here now, what I need to use is what? That 0.6, which is my correlation, the one we computed earlier. So that's going to change this formula, this thing a little. So this one will remain the same. This one will remain the same. So this is what that is going to change. Let me change it. 8.57. Am I correct? This times this is this. This times this is this. So 8.57 times 8.4 4 times 0.56. What am I doing now? Did I have corrected this one before? You did not correct. Two times 8.57 times 0.44 times 0.56 times 0.6. So I'm supposed to have 2.53. That's what I'm supposed to have here. 2.53. 2.53. So when I add everything together, I will have 11.75 plus 25.4 plus 2.53. I have 39.68. 39.68. I take the square root of that. Square root of 39.68 will give me what? The square root will give me what? Square root of 39.68. So 6.3. 6.3. That is the risk of this portfolio. That's the risk of the portfolio. That's the risk of the portfolio. I find the only challenge you have here is how to know this formula. That is a challenge. And of course, it's not difficult to know, honestly. You just know that the first part is here. This first part here is variance of investment A times the weight of investment A in the portfolio. The second part is variance of investment B times the weight, the square of the weight of investment B in the portfolio. So when we are done, the main one is 2 times standard deviation of the A times standard deviation of B times weight of A times weight of B times correlation, or 2 times weight of A, weight of B times what? Times covariance. Anyone you want to use. So if you study the formula closely, you notice that it's a simple formula really to know. I'm not sure it will be given. If you have a past question, you can check whether it is there, but I'm not sure. So we have computed the risk of this portfolio. We have computed the risk of the portfolio, and that has given us 6.3. We now go to the next requirement. By now, you know how to compute risk of individual investment. You know how to compute the return on the portfolio. You know how to compute the risk of the portfolio. So three things we have been able to achieve between yesterday and today. 1, how to compute the return on the portfolio. 2, is even 4, how to compute return on the portfolio, how to compute the weight of the investment in the portfolio, and how to compute the risk of individual investment in the portfolio, and how to compute the portfolio risk. So 4. Let us continue. 3, for the portfolio referred to in one above, calculate the minimum risk portfolio and the expected return and the risk of the resulting portfolio. What are we asked to do here? The question is telling us that what should be the minimum risk of this portfolio? Okay? That is, this risk we computed here, we can still what? We can still reduce it further. So the risk can still be lower than this. So the question is now telling us that what is going to be the minimum risk of the portfolio. So we call it minimum risk portfolio. Minimum risk portfolio. Now, for you to compute your minimum risk portfolio, which is requirement 2 in this case, Abby. Yes, requirement 3 rather. Requirement 3. 1, 2, 3. The issue with portfolio theory is formula. That's the issue there. And find a way, please. So because it is 80% likely that portfolio theory will come out. And if it does, it's going to be, I think, 15 mark. Yeah, it's going to be 15 mark. So I want to construct minimum risk portfolio. Minimum risk portfolio. A minimum risk portfolio simply means what should be the weight of A and what should be the weight of B that will make my portfolio to have the minimum possible risk. So anytime a question asks you to construct a minimum risk portfolio, what the question wants you to compute is what should be the weight of A and what should be the weight such that the risk of the portfolio will be at the minimum. That's what minimum risk portfolio is. Now, to get minimum risk portfolio, okay, let me put the note so that a minimum risk portfolio, is described as the weight. When I say weight, now I'm talking about proportion of investment. So is the weight of investment A, but I will call it asset A. Asset is stated as investment. The weight of asset A and the weight of asset B that will result, in the portfolio that will result in the minimum possible risk. The minimum possible risk of the portfolio. I just gave you that definition so that you should know what you are computing in case you are going through the note again. Mrs. Angela, are you here? Are you with me?
Yes, sir.
Hope everything is fine so far. Apart from the fact that you have to cram formula. You know how to, assuming you are given the formula, you can apply it, Nabi. Can you? I just want to be sure that the only thing you are battling with now is how to remember the formula, not how to apply it. Can you apply it? I think the formula is given to you. Can you apply it?
The problem is to cram the formula.
Not the application. So good. You just have to try. See, by the time you write it 1, 2 times, write it, look at it, try to write it. After like 2 hours, write it on your own again. After like another 2 hours, it will become part of you.
Okay, sir.
And I'm sure most of you here, don't let me say all. You just want to write SFM because I can require that you pass SFM before you can qualify. I'm sure after this diet now, you don't even know where you put your note again because you don't have anything to do with SFM again, Abi. But if God wants to catch you, you now get a job in the multinational company, treasury department. You get a job in the treasury department of a multinational company, then you will know that you cannot run away from SFM. That's why I say if God wants to catch you, you now have to go back. By that time, you go looking for a route. So let us continue. If you want to this portfolio, the first thing is compute the weight of A. That's the first thing I compute. Compute the weight of A in the portfolio using the formula below. What is the formula? The formula is K. Okay, let me say let K. You can use any letter. I want to use W again, that's why I'm using K. Let K represent the weight of A. The weight of A in the portfolio. Let K represent the weight of A in the portfolio. Therefore, my K will be computed as variance of B minus covariance AB, variance of B minus covariance AB, everything over standard deviation of A. Let me write this well with this last piece so that's be nicer. Okay. So I have standard deviation of A I remove square. Standard deviation of A, copy this one again. So standard deviation of A plus standard deviation of B. Standard deviation of A plus standard deviation of B, everything minus everything there, minus 2 times covariance AB, minus 2 times covariance AB. Let me copy this one down. Now, I want you to notice that one thing. We computed weight of A, weight of B yesterday, but I did not use this formula. Why? Let's go back to that, the first one we did yesterday. The first one we did yesterday is this. You can see, I computed weight of A, I computed weight of B. Without that what? Without that formula. How am I able to achieve this? I'm able to achieve that because the question already gave me the return on the portfolio. The question already gave me the return on the portfolio. So if I'm already given the return on the portfolio, I can use this formula to get weight of A and weight of B. But if you are not given weight of portfolio, sorry, if you are not given return on portfolio, if you want to get the weight of A and weight of B, there's no any other formula we are going to use apart from this formula. This K represents weight of A. So if K represents weight of A, then weight of A will be equal to variance of B minus covariance AB over standard deviation of A plus standard deviation of B minus 2 times covariance AB. That is the formula you will need to use. So in this question, I already know my, what do you call it? Standard deviation of B. What is the standard deviation of B? I'll just go there and pick it. Let me check. Standard deviation of B is 8.5. So I put it there. Standard deviation of B, 8.5. So when I square it, it becomes variance. What is covariance AB for the 3.5? I put it there.
It's 8.4, not 8.5.
Sir, Abima?
8.4, not 8.5.
Is it wrong?
8.4.
Is it 0.4?
Yes.
Is this one? No?
This one is.
Is this one that is 8.4?
You're saying deviation of B of A is 8.5, B is 8.4.
So this is B, Abby. This one we computed yesterday now, 8.5. Standard deviation of B.
For A.
You said? This is for A now. For A is 8.57. For B is what? 8.5. So that's what we use there. From where do we have this 8.4? Or maybe we did not check. Okay. Let's check, please. Let's cross-check. This is supposed to be 8.4, Abby?
Yes.
Let me confirm. Take the square root of this. Is
the variance is 71.225.
And the square root of that variance is what? You said?
So if you square it, you get 8.44.
Okay, 8.4. Okay. Okay, good. So this should be 8.4 then. 8.4. Covariance AB is correct, Abby?
Yes.
So standard deviation of A is 8.57. Is that correct?
Standard deviation.
And standard deviation of B is 8.4 minus 2 times covariance AB. That's 2 times 43.5.
Excuse me, sir.
Yeah.
You see, when you are giving us this formula, you said,
When I did that, I can't hear you. I can hardly hear you.
you
Honestly.
said when you were, can you hear me now? Can you hear me
Are
now?
you far away from your device?
No, can you hear me now?
Okay, I can hear you now.
You say that K is equals to variance of B minus covariance of A and B over.
Wait, let me use my earpiece. Maybe I will hear you better. Let me
Okay.
use my earpiece. Maybe that will enable me to hear you better.
Okay.
I don't know whether Mrs. is awake or she has slept off.
I'm
Hmm?
here. I'm here, sir.
You don't say anything, and you just leave us alone today.
Mhm.
You are not gingered.
I'm here, sir.
I said you are not gingered now. You just left us alone, Abby. Make we do am. Voila. Hope you are getting it, sha.
Yes, sir. Yeah, correct.
Now formula be the problem, Abby.
It's not,
Hello.
Yes, sir.
I said na formula be the problem now, Abby.
Yes, sir.
Okay, Mrs. Angela, I can hear you now. Oh yeah, go ahead.
You are in order. Go ahead.
I
I wanted
thought you
to
said
capture what you said. I said I wanted to capture what you said, but I've captured it now.
okay, you captured it. Okay. So let's continue. So what is 8.4 square? Yeah. Square 8.4, what do we have? Eight point square is what? Oh yeah, oh. This is now for take 8.4 square per second now.
$70.56.
70.56. Okay. 70.56. Then add these two together. 8.57 plus 8.4 will give us what?
$16.97.
16.97. 2 times 43.5 times 2.
2 times 43.5. 87.
87. So I copy this. Give me what?
The 70.6 minus 43 points will give us 27.06.
27.06. Then 60.97
97 minus 87.
what do you have?
minus 70.03.
Minus 70.03.
03.
Minus 70.03. Why we have minus?
Is it not supposed this
Oh, okay. I didn't square this.
Hey, that was I
I
was
didn't square
looking.
this.
Supposed to be variance, sorry, not standard deviation.
Variance square, yeah. Variance. Sorry. Is this 1 square? So that's supposed to be what? Square of it should be what? That's this 1 square. Raised to power 2. Raised to power 2.
Square
It's
of
what?
square of 8.57.
Okay, let me add another line.
73.4.
73.4.
44, yes, sir.
73.44. And for this one is what?
70.56.
70.56. Okay. So add that two together. Add the two. Add this and this. What do we have?
144.
144. Okay. So 144 minus 87 will give us what?
57.
57. 57. So K will now be equal to where divide. And K will be what?
0.474. 475. 0.475.
475. So let's say 0.48. Isn't it?
Okay, sir.
Or 48%. That's the weight of what? That's the weight of A. So if weight of A is B, if weight of A is 48%, what will be weight of B? Weight of B will be equal to what? 1 minus what? 1 minus K. Is that correct? Hello?
Yes, sir.
Did you not understand that?
That formula you gave us yesterday.
Yes, exactly. So the weight of A, the weight of A, or the weight of B will be equal to 1 minus 0.48. And what is 1 minus 0.48?
0.52.
0.52 or 52% or 52%. So what does that mean? It means for me to construct a portfolio that will have a minimum risk, I must invest 48% of my money on investment A and 52% of my money on investment B. This will give me the minimum risk of my portfolio. That's interpretation. That's how we get my minimum risk. Did you understand this? Eh?
Yes, sir.
Okay. So look at it too. Minimum risk portfolio and what? And the expected return and the risk of the resulting portfolio. Abi? Minimum risk portfolio and the expected, we are computing three things here. Number one is what? Minimum risk portfolio. Minimum risk portfolio is the weight, Abi, the one we have computed now. Then when we are done, we are also going to compute using that weight now. What's going to be the expected return of the portfolio? And what's going to be the risk of the portfolio? What's going to be the risk of the portfolio? So let's go and compute the expected return of the portfolio. Return on the portfolio will be equal to, how do you compute return on portfolio? Return on A, if you could remember, is return on A times what? Times weight of A. What's my weight of A here? K, Abi, times K. That's my weight of A. Plus expected return on B, times weight of B. What's weight of B? 1 minus K. 1 minus K. So return on P will be equal to what's our expected return? What we computed yesterday?
Okay.
For A, yes.
16.8.
Okay, you have it there. 60 point what?
80.
Okay. 60.8 times weight of A. Weight of A is 0.48.
0.44.
0.42. This one. This one.
Okay.
The new weight that you computed. Plus. What is the expected return on B?
22.50.
Yeah?
22.50.
Sir. Sir.
Hello?
Sir,
Sorry. I went to open gate for my neighbor. He's just coming from the office. Okay, let's continue. So we have, what's the return on B? What's our expected return on B?
22.50.
22.50 times the weight of B, which is 0.52. So return on the portfolio will be equal to multiply 16.8 by 0.48. What do we have?
8.064.
8.06, I think. 0.64. Okay. Plus the other one,
11.7.
11.7 what?
11.7.
So add the two together. What do we have?
19.76.
Eh?
19.76.
19.76%. That is the return of the portfolio. The portfolio that we have weight of 48% for A and 52% for B will give you a return of 19.76. That's what it means. It will give you a return of 19.76. Then the last one is what? Okay, let me put this one. Expected return on the portfolio. Expected return on the portfolio. Then the last one, risk of the portfolio. Risk of the portfolio. So the risk of the portfolio, you already know how to compute that. Risk of portfolio. This is the formula you bring to. That same formula. Risk of portfolio. This same thing is what I'm bringing down. But it's not going to be risk of the new portfolio. You are now using a new weight. All other things remain the same. You are using a new weight now. I just bring this one here. Every other thing will remain the same, apart from the fact that I'm using what? I will now be using new weight. I will not be using new weight. No, don't let me start from here. Let me start from the beginning. Yes. Let me start from here. So instead of having 0.44 now, I will have 0.48. Okay? 0.48. Okay. That's the only thing that will change you. Is that weight, that's the only thing that will change there. All others will remain the same. So all others that we computed before. Okay, let's do it again. 8.57 square will give us what? $8.57 square will give us what?
2.92.
2.92.
So wait.
No, it's not 2.92.
Is it square? Okay. It's not. What of this square root here?
Square root is after you have done everything now.
Okay.
It's square. Yeah.
73.44.
73.44 is 0.48 square. Uncle. 0.48 square will give me what?
Zero point 2304.
Eh?
0.2304.
0.23. Just put it as 0.23. It's 0.48 square. Well, how will it be 0.23? It's 0.48 square is what?
That's what it
It's
gave me.
0.23.
That is it, sir.
0.23.
Yes, sir.
Then 8.44 square.
No, we have been using 8.4.
Okay.
The previous one we were using 8.4. It's 70, okay. 70.56. 70.56.
Okay. 70.56. Then is 0.52 square. Give me what?
Point 27. 0.27.
0.27. So now multiply all this one from here to here. 2.2 times 8.57 times 8.4 times 8.4 times 0.48 times 0.52. Let me change that one before. So multiply everything from here.
So you're blocking the
Okay.
don't know whether I'm correct. I'm getting 21.56. Don't know.
You say what?
I said, I don't know. I'm getting
I don't
21
know what,
point.
like a base calculator you are using. 2 times 8.57 times 8.4 times 0.48 times 0.52 times 0.6. 1 minus 0.48 is 0.52 now. This one here. 1 minus 0.48. That one there.
21 point.
Ah,
I got 21.66.
you got what?
21.66.
Yes.
21.6 Abby.
Mm.
21.66. Right?
Mm.
So now add everything together. Now add everything. Oh, I think we have not multiplied, Abby. Oh, okay. We still have some multiplication to do. I have not multiplied this. So multiply this and this together. What do we have?
I have 57.660.
You say what?
I got 57.60. Everything.
Okay, everything there. Everything from
Yeah,
here to here.
both addition and more.
56
Yes. 57.60.
60. So take the square root.
Got
Take the square root.
7.559.
7.59. So that's the risk of the portfolio. That's the risk of the portfolio. So that's how to compute minimum risk portfolio. Any question on this? Any question on this?
No.
Now, what are the limitations of portfolio theory? Let's see. Limitations of portfolio theory. What are the limitations? I just be dictating this to you. So see. Limitations of portfolio theory. Number 1. Are you there?
Mm.
Now, portfolio theory, don't write here too. Portfolio theory is, if you look at what we did here, we are saying invest 48%, weight of, we're undertaking 48% of project A. So portfolio theory is assuming that project are, but in actual sense, it is not all projects that are what? That are actually divisible. Do you understand? So not all projects are divisible. So I cannot say, oh, undertake 50% of project A, undertake 30% of project B in all cases. So let me put it in better form. Project may be of such size. Project, you can write now. Project may be of such size Are you writing?
Yes, sir.
Yes.
Projects may be of such size that they are not easy to divide. That they are not easy to divide. That they are not easy to divide. in accordance with the recommended diversification principle.
In accordance with the recommended.
Diversification principle.
Excuse me, sir.
Yeah.
Excuse me. Why don't we leave this notation and read it up in the park so we can solve another question?
Okay, so I should leave this one, Abby.
Yes, please. For example,
Okay.
I have more questions.
Let's go to the next example. You are considering investment in one or both of two securities, X and Y, and you are given the following information. You are considering investment in one or both of two securities, X and Y, and you are given the following information. Security X, possible rate of return, probability of occurrence. Security Y, possible rate of return, probability of occurrence. You can see the difference between this one and the one we just solved. The one we just solved, both A and B, they have the same probability. But look at this one now. The probabilities are different, right? The probabilities are different. So what are we going to do? The grant says required. Calculate the expected return for each security separately and for the portfolio comprising 60% X and 40% Y, assuming positive correlation between the positive return. Are you there?
Yes, sir.
Okay. So how do we do this? The first thing the question wants us to do is that we compute the expected return of security Y separately, and we compute expected return of security X separately. Can you quickly do that for me now? Compute the expected return for me. Expected return of X, expected return of Y. What are you supposed to do? Hello?
We are doing it, sir.
Okay.
For security S.
Yeah. What do you have?
25.
25, Abby?
Yes, sir.
What about for Y?
$46.
46. Okay, Thank you. Thank you. That's the expected return. Now, that is the expected return of each of the security separately. You can now say we should also compute and for the what? For the portfolio comprising 60% of X and 40% of Y. If I have a portfolio that is having a weight of 60% for security X and weight of 40% for security Y, what will be the expected return on that portfolio? Assuming possible relation between the possible rate of return from share comprising the portfolio. You know what positive correlation means? Increase in return of one will lead to increase in return for the other. A decrease in return for one will bring about a decrease in the other as well. Now, if I want to compute the return on this portfolio, now let me do this. Example 2. Example 2. I'm still going to start with the one we have done. No problem. A, because I'm still going to need it. Computation of expected return on the investment, sorry, on X and Y, and for the portfolio. Portfolio. So, expected return on X, you got it right. I just want to, because we are still going to need it. That's why I want us to do it. What you did is perfectly okay. So I have my return I have my probability, then I have expected return. X. Okay. So what are the returns? We have for A. Do you have the question with you?
Yes, sir.
What are the returns for X? Is what?
30, 25, 20.
30, 25, 20. What are the probabilities?
0.3, 0.4,
3, 0.4,
0.3.
3. So multiply. 0.3 times is 9, Abby. Am I correct? Is it 9?
Yes, sir, it's 9.
0.4 times 25 is what?
10.
10.
10,
Yes.
yes, sir.
Okay. Then the last one is what? 6. So I'll add this together. I have to give me 25. So I have 25 expected return for X. What about for B? Let me just copy this one and replicate it for B. expected return for B, sorry, for Y, I mean, not B, for Y. What are the returns for Y?
50 and 40.
Okay, just two, I mean.
40, yes, sir.
50 and 40. What are the probabilities?
0.6 and 0.4.
So the last one here we go. The last one we go. So 0.6 times 50 is what?
30.
Then 0.4 times 40 is what?
16.
Oh, yeah, now.
The total 46.
Is 0.4 times, okay, 46, this is 26,
16.
16.
The first one is 30.
The first one is 30.
Okay. So total is 46.
46.
So that is the expected return on the portfolios. Sorry, on the separately. Now, web portfolio, return on portfolio. I'm going to use a table for this so that the work will be easier. Now, return on A. Return on A. R can put as R on A and return on B. Okay, let's do this. Don't let me go through that long route. Return on A. Okay. What is the percentage of return on A? 60, Abby? Is 60 or 40?
Okay.
60.
60x.
60 of X, so it's 0.6. Okay, X, not A, sorry.
Well, yeah, X and Y.
X, yeah. So 60 of X and 40 of Y. R of Y, 40%. Or in short form, make it short, you can just put it as what? It's 0.6 of X and 0.4 of 4. 0.4 of Y. What am I doing now? 0.6 of X, then here is 0.4 of Y. Let's make it short. 0.4 of Y. Now, what we will now do is that you go to this one here. we're going to be doing permutation and combination. So let me go and put it. I could do the return on those for x. For x, I have 30 what?
25,
30, 25, 30, 20, I mean,
20.
25, 20. For y, I have 40, 50, and 25, I mean.
Yes, sir. 50 and 40.
Yeah, 40.
Okay. So this is what I'm going to do. We are going to do what we call combination here. You say that you have this, when you pick this, you say that you have 30 for x, 50 for y, or 30 for x, 40 for y. That's the first thing I'm going to do. So what I'm going to do here is this 30, 30 times 0.6 will give you what? 30 times 0.6 is 9.
18.
Abi?
18.
Oh, sorry. 18 rather. 0.6, 18. Then you now come here. 50 times 0.4 is what? 420, Abi?
20.
So, you know, I'm still picking this, Abi. I'm looking at a combination of 30, 30, 50, 30, 40, 30, 50, 30, 40. Are you getting it?
Okay.
I'm picking this one. When I'm picking this one, I will assume
Yes.
that it's either this one and this one will occur together,
Mm.
or this one and this one will occur together. Do you understand?
Yes,
It's either I will have 30, 50, or I will have 30, 40. So that I would have completed that of what? 30. Before I move to what? 25. If I come to 25, I will have 25, 50, or what? 25, 40. When I will move to 20, I will have 20, 50, or what? 20, 40. That's what I'm going to do.
Okay.
So, $30 of this will be 18. There, Abby. And 40 times 0.4 will be what?
Sir, sorry, please explain this thing again.
These are my return on A, Abby, on X, Abby.
Yes, sir.
And these are my return on B, on Y.
Mm.
Now, I'm now saying that you are picking this one of them at a time. If I pick 30, I will assume that it is possible for me to get 30% return on X, and at the same time get what? 50% return on Y. It is also possible that I get 30% of X, but 40% of what? Y. So I'm picking them at a time. It's either this one and this one will come, or this one and this one. This is a matter of probability here now. Do you understand?
Mm.
When I'm done with that, I come to 25. It's either 25 and 50, or what? 25 and 40. When I'm done, I will come to this. It's either 20 and 50, or 20 and what? And 40.
Okay.
Is it clear?
Yes, sir.
Okay. So, $40 times 0.4 is what?
16.
16.
16.
Good. So I'm done with 30. I will now come to 25. 25 times 0.6 is what?
Fifteen.
15.
15.
15. Then 50 times 0.4, 20. I'll come again. 15. Then this time around 40 times what? Times 0.4 is what? 16. Did you understand that?
Yes, sir.
I'll now come to 20. 20 times 0.6 is what?
12.
12. Then this will be what? 20. 12 again. This time around I have what? 16. Do you understand now? So these are the possible return I can have. These are the possible return I can have. The possible return. These are all the possible return I can have. Now, what will now be the return? Return on this portfolio. The return will now be what? The addition of the two. So here is going to be what? 38, right? Here is going to be, the next one is going to be 34. The next one will be 35. The next one will be 31. The next one will be 32. And the next one will be 28, if I'm not mistaken. Yeah. Eight. Now, I will now have to calculate. You know what I want to calculate is expected return on the portfolio. This is not expected return because I've not multiplied them by probability. So I need to bring my probability here. So my probability. Now ask me, what is the probability we are going to use now? Since we have different return, what is the probability we are going to use? You need to use what we call joint probability. You use what we call joint probability. Now, when we are considering 30, what is the probability of 30? What is the probability of 30? 0.3, Abi? Then for 50, what is the probability of 50? When we consider this, the probability of 50 is 0.6. So you will multiply 0.3 by 0.6. Let me put it there as joint probability.
Probability of 30 is 0.6.
0.6.
Yes, sir. And the probability of 50 is 0.4.
Why do you have 0.6?
That's what we. Okay. Okay.
So what do we have? 0.3 times 0.6. Probability of 30 is 0.3. Probability of 50 is 0.6.
0.6.
So 0.6 times 0.3 will give us what?
0.18.
0.18. Now come again. Probability of 30 is 0.2, 0.3. Probability of 40 is what? Is 0.4, right?
Yes, sir.
So multiply 0.3 by 0.4. What do we have?
0.12.
0.12. Then you now come to 25. Probability of 25 is what? Is 0.4.
0.4.
And probability of 50 is 0.6. So if 0.4 times 0.6, give me what?
24.
It can't be 24 now.
0.24.
0.24. Then probability of 25 is 0.4. Probability of 40 is also 0.4. 0.4 times 0.4 is what?
0.16. 0.16.
0.16. 0.16. Then you now come to 20. Probability of 20 is 0.3. Probability of 50 is 0.6. So we're going to have 0.18. Probability of 20 is 0.3. Probability of 40 is 0.4. So 0.3 times 0.4 will give me what?
0.12.
These are the joint probabilities. When we are now done, you now multiply this return by the probability to get the what? The expected return on the portfolio. So 38 times 0.18 is what?
8 times 0.18. 6.84.
6.84. Next one.
4.08.
4.08. Next one.
8.4.
8.4. 8.4. Next one.
4.96.
4.96. Next one.
5.76.
5.76. Next one.
3.36.
3.36. 3.36. So total everything, that's our total expected return. That's our total expected return on the portfolio. Sum everything together.
$3.4.
33.4. So that's requirement A. That's requirement A. We have computed expected return on each of the security and expected return on the portfolio. The portfolio now is the expected return on the combination of what? Combination of the two securities. Let's go to requirement B. This says we should calculate Please, I want to, is it possible for us to hold another class again?
Yes, sir.
Hmm?
Yes, sir.
Tomorrow.
It may not be tomorrow. It might be maybe Thursday. You know, this is why I'm saying that. We still have some aspect of portfolio that we have not covered. Alpha value.
Better.
I need to teach you alpha value. I need to teach you how to compute beta. Then I will now illustrate that using one icon pass question so that it will clear everything on how to compute beta. You can compute beta for shares. You can compute beta for bonds. And that was exactly what I can set 2 days ago. So I need to clear that for you. That's why I'm
Yes, sir.
soliciting for one more class.
Yes, sir.
Okay, thank you. So requirement 2 says, ma'am,
The same time, ba?
the same time, yes. The same time. Calculate. It's not convenient.
No. How? Wait.
You know that when we are doing this, nobody is giving me pleasure. You understand? That's why I even prefer this one. If I'm in the office, I won't be able to. If I'm doing it, they will be calling me. I'll go and hide myself. Those times I used to do lecture, they won't know where I am. I'll just go to one of the rooms, especially the boardroom. I will lock myself inside and be lecturing. But it does not work always, especially when there's work to do. You understand? But now we can do it until when we want to stop. So sorry for the inconvenience.
No problem. It's not an if we had been using this time, sir, we could have covered.
Yes. So B, calculate the expected risk for each security. Okay, expected risk. Okay. Calculate the expected risk. You know the other one. A is expected return, Abi. B is expected risk for each security separately and of the portfolio as defined above. For this purpose, the measure of risk may be taken as a standard deviation of probable variances from the expected rate of return. So anytime they ask you to compute risk of portfolio or risk of investment, you are using what standard deviation when you are dealing with portfolio theory. Do you understand? So we are going to compute the standard deviation of each of the securities and standard deviation of the portfolio. Now, I can just compute the standard deviation of the portfolio here. And for the security here, I can equally compute the standard deviation there. So I will compute each of them here. So R, let me just do it once. I don't want to waste time. Probability, this the same we did yesterday, it's not different too. And R minus this square. That's variance, Abby. So you know that's variance, Abby.
Yeah.
So what am I going to do? I will pick 30. 30 minus 25 square times 0.3. 30 minus 25. I will square it. I will now multiply by the probability. What do we have?
7.5.
7.5. Then the second one, 25 minus 1, that one will be 0.
0.
The next one, 20 minus 25 square. That is 25 square times 0.3. Will give me what?
7.5.
7.5 as well. Sorry, 0.5. So add the two together. We have what? 15, Abby?
15. Yes.
We have 15. So I will now take the square root of what? I will take the square root of 15. So risk of x, that's the standard deviation of x. Standard deviation of x is risk of x. So risk of x, risk of x is equal to, let me go and copy my standard deviation. Sorry,
3.87.
my square root. Let me copy my square root. Square root of 15 is what?
3.87.
3.87. That's the risk of investment X. I do the same thing to investment Y. For investment Y now, I have probability into bracket R minus this square. So for first one is 50 minus 46 square times 0.6. That will give me what?
9.6.
Eh?
9.6.
9.6. minus 46 square times 0.4.
14.4.
14, Abby?
Yes, 0.4.
14.4. So add the two together. What do we have?
24.
$24.
Yes.
24. So what's going to be my risk? Risk of this portfolio, the standard deviation of Y. Standard deviation of Y will be equal to
4.9.
24, which is what?
4.90.
4.90. 4.90. So I'll do the same thing for the portfolio. 18 minus 33.3 square. So I will have probability brackets R minus risk of portfolio. Ma'am?
I want to understand the reason why we had to use this risk of portfolio. Is it because the probabilities are not the same?
Yes. The
Okay.
probabilities are not the same, one, and the number of return are not the same. This one has 3, this one has 2. Do you understand?
Okay, so
You know, one has 2, Abby. The other one has 3. They are not
yes.
the same. So that's the reason why you have to do this. So when you have different probabilities, you are using this. When you have different returns, you also using the same thing. Do you understand me?
Yes, sir.
Okay. So 18 minus 33.4 square is what?
Hmm?
18 minus 33. 18 minus this square. Is what?
237.16.
237.16. Okay, wait, so times the probability.
Yes, times 0.18.
42.69. 42.69.
40. 42.
42.9.
42.69. Okay. The next one.
Excuse me, sir.
Yeah.
Is it not this R we're taking? That is 38. 38.
Which 38? This one now.
No, the first one. Is it not our R?
This one here. This one.
Yes.
And now
38 minus
38 minus 33.4 square.
Okay, okay.
That's
That's not
this.
You
what
said
that's
18.
not what I did. You said 18.
Okay. I said 18, Abby. No. Is this one now? We are not using this one again. We have combined them already. This is the one we are using. Sorry.
Okay. That
This
one
one is
is wrong. Yes, sir.
.81.
3.81. Next.
Zero point zero four.
0.04. Okay.
Zero point 61.
0.61.
0.92.
0.92.
Another one, 0.35.
0.35.
3.50.
3.50. So add everything together, that's the variance. When you add everything together, that's the variance.
$9.23.
9.23. So what's the risk? The risk of the portfolio.
3.04. 3.04.
The risk of the portfolio. $9.23. That is equal to what?
3.04.
3.0. See the way we computed this one. See the way we computed the second one. And you know the reason for approaches now. Because the first one, we have the same probability, equal number of returns. But the second one here, different probabilities, different number of returns. So where you have different probabilities, different number of returns, this is what I'm going to do. And even if it is different probability and the same number of returns, we are still doing this. You have to take this approach. So, any question? I think we should stop here for today so that I can go to bed and wake up for office tomorrow. Any question on this?
So you've not sent the last.
I've sent everything. I sent 2 videos today now.
Yes, that was yesterday's one, but that's option. The last part, all option, eh? Sir?
I sent class. I sent it today. I've sent it.
You sent
Pricing theory, session 2. Portfolio theory, session 1. I sent it to today. This is it now. How are you now?
Okay, maybe I've not seen it.
Don't check the group now. I've sent.
Because
I think
portfolio
the first
option.
when I go to it. What do you say?
Okay.
I didn't hear you.
Okay, I will check. Let me check. Thank you, sir.
I'm coming. So I sent portfolio to. I didn't send it.
Yes, sir. That's what I'm talking about.
That's where did I send it? Send it to myself. I'm coming. Let me check. I've done the 2 today. Let me check my phone. That was the first thing I did this morning. So let me check before we collect it. Yeah, well, much. When there is pressure at all, that's how it is. So you can see it. You see option pricing to section 2. You see that I've uploaded it. I thought I've copied and sent to you.
Okay, sir.
Get link. I'll send it right now. You see, I was arguing that I've sent it to you. I didn't send it eventually. So, option pricing theory section 2. You see that?
Yes, sir.
All right, thank you. Section 2, yeah. So I will download this one when I get office this morning by God grace. I'll send it to you immediately. All right. Have a wonderful night rest.
Good night.
Nice.
Good night, ma.